So as I say, I'm going to try and make this quick and a bit fun because this is about the TV. And when you're not here having a nice meet-up and eating pizza and drinking beer, you're probably eating pizza and drinking beer in front of the telly at home. So I'm going to talk to you a bit about how some of that happens. And this is going to be a bit interactive. So having had some pizza and some beer and some quite intense talks, I want you to look out for your favourite TV shows and tell me what they are when you see them.
It's quite quiet.
It's quite quiet?
Yeah.
Okay, I'll try. I'm not used to this silent disco arrangement, but we'll try and make it work. My name is Paul Markham. I work for Red Bee Media. I'm going to talk a little bit about them in a minute. I've been working for Red Bee Media for a few years. Before I worked for Red Bee Media, I worked in the radio industry. I've pretty much been working in broadcast in one form or another for about 20 years. Broadcast, you might think, is a bit like IT, and these days it kind of is, but there's still a lot of kind of legacy in broadcast. There's a lot of old school thinking and old school technology that we have to work with and work around. So today is a bit about Red Bee Media. It's looking at what our challenge was, what our customer wanted, that was a bit of an esoteric requirement. What we built to meet that challenge, to solve that problem, how we made it resilient, because I guess resilience is kind of everything in TV, and what do we learn from it? So I'm going to very quickly run through what Red Bee Media does, and then we'll get on to the fun stuff. Red Bee Media has clients all over the world. We help people make their telly happen. All of these clients that you have here, you can see we've got some major UK broadcasters in the middle. I can't tell you who the solution we built today is for commercial reasons, but it's one of those guys in the middle there in that centre block. It's one of your major TV broadcasters in the UK. What do? We do anything to do with making video, making TV happen. So we get video in from production companies, we make subtitles, we make audio description, we process the video into different formats, we make sure that it's in the right place at the right time to get onto the TV so that everyone can watch it. And when you turn on your TV at home, it always works, right? You never turn on the BBC or Channel 4 or ITV and get a frozen picture or something buffering or anything like that. And the reason for that is because we think we're pretty good at this, right? And actually all of that video, all of those TV channels are being played off video servers. They're being played by, they're all digital, they're being played by computers. And the fact that it all works all the time is really down to I'm not going to say it's down to me, it's down to a lot of my very clever colleagues who work in White City. You've got some numbers there. I won't read them out. Let's just talk about the thing, because that's really what you're here for. As I say, look out for the TV shows. Want to get a bit of... I've got the mic here. I'm going to sort of point it at you if you can spot a TV show. Let's start with this one. Show? Anyone?
Fargo.
Fargo. Thank you very much. So, like Fargo, I'm going to take a bit of liberty with the truth here. I'm going to go through something that is, it's a nice talk, and it talks a lot about how we did something, and it's based on the truth. But the details have been sort of glossed over. All right? So I know that one or two of my colleagues are in the audience. Don't come to me afterwards and say, that's not really how it is it? It's not. I know that. That's not the point. The point is it's simplified so that it makes a good presentation and it shares the vision of what was made. Show? Crystal Maze. What was the challenge? Well, we've got hundreds of video files and subtitle files and audio description files, and they all need to be in the right place at the right time, because we've got all of those channels all around the world 30 to 40 programs a day. The video files are pretty big. You've got to think about the I/O on the servers that are holding the files. You don't want somebody to suddenly transfer gigabytes, terabytes of data onto a server and it to grind to a halt while it's playing out the telly. And we need to think about backup and DR. So the way we make sure that that TV works all of the time is we have a backup, and then we have a backup of the backup, and then we have a DR of the backup of the backup. So there are layers and layers of resilience so that if something goes wrong, we can very quickly switch to something else. And I guess that makes the logistics harder, because everything doesn't just have to be in one place, it has to be in all of those different places. It's kind of a production line show inside the factory. It's Greg Wallace. With a production line of toilet rolls. Somebody once said to me that TV playout's a bit like a production line of toilet rolls. It depends on the quality of the telly that's going on. It's not all great. Some of it's better than others. But yeah, it's like a production line because we've got thousands of channels, we've got thousands of programs, we've got thousands of terabytes, petabytes of storage, and everything has to be in the right place at the right time. It's not a show.
Groundhog Day.
Groundhog Day. So, we're getting the idea here. Watching some channels is a bit like Groundhog Day because they play the same stuff over and over again. And they might be repeated on the same day, might be repeated next week, might be repeated in 10 years' time. But normally, in order to meet that requirement, we send the files, the big collection of files, we send it again. So if it's on again today, we'll probably send the video, the subtitles, the audio description. We'll just send it all again. When it turns up on the schedule, it's back on the schedule. Send it again. And sometimes we have to send stuff again for operational reasons. Sometimes there's been a problem. We don't know if stuff's got there. Sometimes you have to just say, well, resend. Make sure it's there. Make sure everything's in place. The reason I'm going through this will become clear in a second. So we had a customer, as I say, major UK broadcaster, who came to us with this kind of weird requirement. And they said, in our new system, we can't process files that we already have. We only want you to send them to us once. So we said, yeah, okay, we can do that. Yeah, that's fine. And then they said, unless we've house kept them. And so, so do you housekeep them, what, every day? After a week? After a month? No. They just delete stuff when they've run out of space. So how are we supposed to know what they have and what they don't have? And this was a genuine conversation that happened with the client. Obviously, bit more detail, but that's the gist of it. And after a bit of head scratching, they came up with this. Well, we could probably send you an inventory. Every so often, we'll send you, dump you out a whole list of what we got. This is thousands of things that will be sitting on the servers at any one time. It's not a half a dozen. It's literally thousands, a list of thousands of items. So, just to summarize, normal workflow. We get the schedule, we go through the schedule. Oh, there's this program, there's this program, there's this program. Have we got the bits for that? Have we got the bits for that? Okay, we'll send them off, get them all ready. And we'll deliver them to the endpoint. And if it comes on the schedule again, we do it again. Brilliant, easy, no problem. But what the client wanted was this. They wanted us to do the schedule media delivery, and then they wanted us to wait for the inventory, and according to the inventory that they sent back, redefine what we were going to send them, and go round in this loop. And so, compared to this nice, simple, transactional logic that we have here, we suddenly have this state that we have to maintain. And I guess the crux of this point solution, let's call it, that we came up with for this requirement is about how we resolved that problem, what we built, and how we made it So is this a grand design? I think you can be the judge of that. Some of my colleagues probably would say not so much, but we'll see what you think. Game of Thrones, a raven with a scroll, if you can't quite see it. So the customer sends the inventory every 6 hours. We stick the inventory in an S3 bucket. We're using AWS. I know that Bulb are using GCP, and that's really cool, but we're just kind of getting to grips with AWS. S3 bucket triggers a Lambda script, and what the Lambda script basically does is it dumps a DynamoDB table, loads the contents of the inventory into the DynamoDB. And the nice thing about that is that every time we get an inventory, we're basically resetting that state again. So we don't have to keep the state forever. We can kind of say, okay, here's an inventory, throw it all away, let's start again. Anyone? Twin Peaks? Agent Cooper? I've heard he likes coffee. So special agents. We have special agents for our legacy systems, and what this one is doing is it's looking at the schedule and what is ready to be delivered. And it's doing this every hour. And it's going to send a list of all of the things that are ready to be delivered to another S3 bucket, a second S3 bucket. There's another list, another bucket. We had a legacy challenge here, and we used a Golang agent, which I'll talk about a little bit later, but it's kind of we found it's a really good way to kind of sidestep all of that Java versioning, dependency, endless cycles of testing kind of hell. Because Golang was just a self-contained lump of executable, chuck it on the legacy server, everyone's happy. We don't talk about him, but we then compare, okay, that's the reason that he's there, we compare what came from the schedule, remember all that stuff that was ready, we compare it with the inventory, and we say, okay, what's ready that isn't in the inventory? So what is it that we need to send? So we're looking for the delta, if you like. And once we get that list, we stick them in SQS. So we can fill SQS with a whole load of messages of stuff that needs to be sent. And we also add them back into the DynamoDB table. So the next time this runs, the DynamoDB table is maintaining that state and it doesn't send them again. Breaking Bad. Oh, whoops. Jumping ahead there. So we've got delivery agents, similar concept. The delivery agents sit and read the messages from the SQS queue. Basically it delivers every item from the SQS queue. Again, another Golang piece. So yeah, very simply, that's what we've got here. Inventory comes in, updates the database. Every time we get a schedule or a ready schedule with all the list of stuff that's ready, does the delta, fills the queue, queue drives the deliveries. Brilliant. Except, you remember all of those different systems that I talked about, those backups and stuff? This makes it kind of awkward. Show Rick and Morty. Rick and Morty with their split brain. So obviously, the requirement from the client was we only want it once. What they meant by that, by the way, was they only want it once at their main server and once at their backup server. And so we have multiple sites too, and they have multiple sites, and this still has to be an only once thing. So this is what we did to solve that. So I said inventory every 6 hours. This is a clock. The inventory comes in at midnight, it comes in at midday. from one site. From the other site, it comes in at 6 and 6. So it's every 6 hours, but we alternate between their two sites. And their sites are, in theory, linked together at the back end. And so we should get, if everything's working, we should get the same inventory whichever site it comes from. On our side, we do it every half an hour. On the hour, on the half hour, on the hour, on the half hour, we generate our ready list. And the ready list comes from the two different sites. And it gets fed into the bucket. And the nice thing about this is stuff can be ready at different times on different sites, still works. So every time it lands in the bucket, we do the compare, we generate the SQS messages, everything's cool. Then the delivery agents, so there's two of them too, but they're consuming the same SQS queue. So each time the delivery agent pulls a message off the queue, it says, oh, have I got this file? Yeah, it's all good. Send it. And then the delivery agent can send it to both the customer sites. If the other delivery agent picks up the message, sends it to both the production sites. If for some reason something hasn't quite synced up, and one of the delivery agents looks on its local system and says, oh, I haven't got that file, can release the message back into the SQS queue, let the other one pick it up because it must have been there when it was originated. And with that, we've kind of solved our resilience problem. Because any of these sites, our site, one of our sites, one of the customer sites, can be, on fire, disappeared into time warp, whatever, and the whole thing still works. We might lose a bit of the inventory fine grain, but we're still topping up that DynamoDB every time we send something. So it shouldn't matter. Obviously, if it was offline for ages, probably would matter. We'd ask them to double up or send one of those more frequently. And if we add a little bit more detail, you get this. And I guess the real thing we're leveraging here is all of this serverless infrastructure in AWS in the middle, because we're kind of banking on the fact that that's pretty resilient. It's multi-AZ. It's, Amazon don't promise you 100% because why would they? That would be silly. But it works better than most things. It's certainly more reliable than most of the stuff that we run internally, quite honestly. So we've never really struggled with that. So there's one SQS queue, there's one DynamoDB, but they're pretty resilient, they're pretty strong, they're always there. And we can run the multiple sites around them, everything kind of works. Couple of notes on the security front. All of our comms going here, there, and everywhere into this system from our on-prem platforms. It's all HTTPS encrypted, which keeps the security people quite happy. It's all, it can go over the corporate web proxy if necessary. And ultimately, what ends up in AWS, in these cloud environments, is it's not confidential data. It's not even that mission critical because we've got so many kind of different things going on. It's just a list of IDs, really. So we don't have to get too hung up on next week's telly turning up on the internet somewhere it shouldn't be, which obviously is something that our clients don't want. Yes. All right. So we're nearly at the end, right? We can have the cake soon. What did we learn? I know people do this serverless stuff and they stick up the bill and they go, "Oh, isn't it so small?" Yeah. So I'll do that. Let's just get that out of the way. We spent in 1 month $3.14 on Lambda. 1176 on SQS. It's pretty heavy stuff, isn't it? Obviously, you've noticed that this is a bit of a Pac-Man, and there's that big chunk of DynamoDB, and this is one of the things that isn't quite right about the solution. The DynamoDB, we'll talk about it a bit more in the next slide because that's the lion's share of the cost. And if you go to the things we learned up here, DynamoDB was just the wrong choice for this, because it's too expensive. And weeks after we built this, Amazon announced S3 Select, which would have actually done the job a lot better. But we'd already built it by then. I'm just going to go down the right-hand side here and just talk through these things that didn't go so well, and we'll come to the good stuff towards the end. The inventory updating thing. So I guess there was a bit of a race condition in there that I hadn't anticipated, and that is that we kind of assumed that if we'd sent a bunch of stuff to our client, and then quite soon after they'd sent us an inventory back, that the inventory we got back would include the bunch of stuff that we'd just sent. So yeah, as you might expect, it took, on their side, it took time to process the stuff that we'd send them, add it to the inventory that would then come back to us. And so if you think about these inventories only coming in every 6 hours, that timing didn't always work so well. And sometimes stuff ended up getting sent twice. User interface. So I don't know if anybody else has had this experience, but when we conceived this, I guess we thought, well, this is a bunch of kind of back-end metadata kind of stuff that is hopefully conceptually pretty simple. Yeah, maybe we don't really need much of a user interface, because user interfaces are quite expensive, aren't they? They take a lot of time to build and mess around with. I think this was a real learning, because when this didn't work quite as well with the thing I just talked about the timing, without a user interface that we could give the support people, it was a bit of a nightmare. Because although the guys who built this understood all of the moving parts, of course, once they're moved on to the next project, the support guys are kind of left with this weird serverless thing that they don't understand. And yeah, I think a user interface, a basic user interface, is something that you always need to build on a supportable platform. It needs to show that it's doing what it's supposed to be doing, and if it's not doing what it's supposed to be doing, where that problem might be. On the positive side, this is the last slide, by the way, so you get to the cake in a minute. On the positive side, this was a quick build. I mean, this was a couple of years ago that this was built now, but it was done in about a couple of months, which in the broadcast world is pretty, pretty crazy. You couldn't deploy something to live in a couple of months normally. And obviously, it's been pretty cheap. We've had no resilience problems in terms of the different bits and moving parts, just some niggles around the integration stuff. And yeah, the agents, I guess the Golang that I talked about that we could deploy onto legacy servers, that's worked really well. That's been one part of the solution that's absolutely perfect. Sidestepped a whole bunch of problems with legacy servers. So yeah, that's about it. I hope that was interesting for you. I hope it was fun, and thank you very much.